All right. So here we are about to talk about alternating series. And if you're watching this video, I posted another video that was much more detailed than this one is going to be. This one is just meant to be something very quick and fairly easy as far as this kind of thing goes to get you acquainted with how this works. Okay? So this is the basics, in other words. Now, alternating series is probably just what it sounds like. It's we'll say for us, like we'll deal with only with infinite series, but it's an infinite series whose signs, whose terms have signs that consistently alternate between positive or negative and positive. So, like, take this first one, for example. This is an example of an alternating series. Uh, Alternating series might typically have this -1 to the n power or something like that, and that's what makes the signs change from one term to the next. But let's look at a few terms of this just so you can have a feel for what we're dealing with. If you put 0 for n to find the first term of the series, you'll get 1, okay? And then if you put 1 for n to find the second term of the series, you'll get -1/2, all right? And then if you put 0, 1, 2 for n, you'll get +1/4. And if you put 3 for n, you'll get -1/8. So if I just do the calculations and find the terms, then they do alternate from positive to negative to positive to negative, and that pattern would continue forever. Okay? Now this series also happens to be geometric. All right. So we still might see, or I guarantee it, we'll still see geometric series. Okay? But it's, for our purposes, now it's going to be an example of an alternating series. You could tell me what this series converged to if you wanted to. Why not? It's a geometric series. The first term is 1, and r is -1/2, right? So it will converge to, what was that formula? We use the capital letter S to give the number that a series converges to. A1 over 1 minus r. So that's going to be 1 over 3 over 2, so that's going to be 2/3. So you can get your calculator and do a little experiment if you want to. You can take 1 minus 1/2 plus 1/4 minus 1/8 and keep going. Every time you add or subtract that next number, the grand total will be a little closer to 2/3. All right, you can verify that with your calculator if you want to. That's what it means when I say this series converges to 2/3. But it's an example of an alternating series. Let's look at another one. What about this one? -1 to the n over n. We can even make this one a little different than the other one. Why can't it be -1 to the n plus 1? I think it can be. It's not going to matter. That's still going to be an alternating series. All right, so what's the first term of this one? The first term is +1, right? If I put 1 in to find the first term, I get -1 squared. That's 1 over 1. My next term will be negative. When I put 2 in, I'll get -1 to the third power. That's -1. So I'll get -1/2, and then I'll get +1/3, and I'll get -1/4. And then from there on, it's a bunch of pluses, all right? Okay, or from there on it's plus and then minus, it continues. I didn't mean to say it's a bunch of pluses, but the terms alternate from being positive to negative to positive to negative and so on. So that's an alternating series. Now, I don't know what this one converges to. That's not easy to figure out. This is not geometric. All right, let's agree about that at the very least. It's definitely not a geometric series, but it is an alternating series, so we can agree about that much about it. So now you know what an alternating series is. A series whose signs change consistently from plus to minus or minus to plus, but they alternate. All right. So our next issue is, how would you know if an alternating series converges to something? So let's just, for generic terms right now, take this as an alternating series. So suppose that's an alternating series. There's just two things to verify. An alternating series will converge if at some point in the series any term is more than the next term. Okay? All right, it doesn't have to be at the beginning, but there's got to be a point in the series where after that point, any term is bigger than the one that comes after it. Okay? And then there's another thing that has to happen. The limit, as n goes to infinity, applied to the absolute value of that formula is 0. Okay? And here, like, I want to emphasize, it's not that any term is bigger than the one that comes after it. It's that absolute value of any term is bigger than the absolute value of the one that comes after it. So it's like for both parts of this test, we're going to forget the fact that the signs change. All right? So you can see, like, that's true here. Isn't 1 bigger than a half, and isn't a half bigger than a third, and isn't a third bigger than a fourth? Yeah, so the absolute value of any term is more than the one that comes after it. It satisfies the first part of the test. And, is it also true that 1, a half, a third, a fourth, is it true that the individual numbers are going to 0 ultimately? That's also true. So this series would converge. It would do both of these. All right? But that's all you have to verify to know if an alternating series converges. An alternating series will diverge if the limit as n goes to infinity of the absolute value of that formula is not 0. That's all you have to do to prove that it's going to diverge. All right. So at this point, we know what an alternating series is when we see it. We know how to tell if it converges. We know how to tell if it diverges. All right. So let's look at some examples. So in this video, I won't get into any complexity at all about that proof, okay? Like, I'll take it will be, for the problems we initially see, evident that either the terms get consecutively smaller and they go to 0, or that the terms don't go to 0. You prove both of these, or establish both of these to prove it converges, and you establish this only to prove it diverges. So anyway, what about this one? Does that converge or not? Well, it looks like it's going to be an alternating series. Let's see, though. First term is going to be negative 1/3. All right. Second term is going to be positive 1/9. And third term is going to be negative 1/27. And I'll take it as self-evident that, yes, it is alternating. The signs will change from minus to plus. And the terms are getting consecutively smaller with a formula such as this. That will happen. 3 to the first power, second power, third power, fourth power. And then the terms are going to 0, right? Okay, so this one will converge. It does both things that an alternating series has to do in order to converge. This is also a geometric series. All right, I used another example that was geometric. So you could also figure it out that way. Okay, so I'll put like, all right, it converges. And the way I've talked about it is I tried to get you to see that it does both of these things. But we could also say that we know that it is going to converge because it's also a geometric series where r is negative 1/3. What's a geometric series have to be like in order to converge? R's got to be between negative 1 and 1. What about this one? That one should be easy to tell also, right? That's this one that we already looked at over here. Okay. I'll write out a few terms just for completeness. I feel silly leaving it blank, but 1 minus a half plus a third minus a fourth, and it goes on from there. And yes, it is true that any term is bigger than the next term, and the terms are going to 0. The ultimate limit of that is 0. Okay? But let me talk about, like, in some of the harder problems, what we might do. Like, what is, I'm just telling you, well, those terms are getting closer to 0. They'll get as close to 0 as you can imagine. But for the sake that we'll run into this again, what do I mean when I write limit n goes to infinity absolute value a sub n? Then that's going to be, in this case, limit n goes to infinity what would this be like if you took the absolute value of it? Wouldn't you just lose the negatives? And what element of this formula is responsible for giving you sometimes a negative number? It's that negative 1 to the n plus 1. That's the thing there that is either going to be a 1 or a negative 1. So if you wanted to take the absolute value of this, it would just be a matter of dropping that negative 1 to the n plus 1 power. So our limit right here, this one, the absolute value of that is just 1 over n, okay? And then that limit is easily seen to be 0. Okay, yeah, so the terms are going to 0. It also converges, okay? All right. What about this one? That kind of looks like it might be an alternating series. It looks like the others, sort of. It's got the negative 1 and the power. But maybe we should look closely at this one. 2n, that's always going to be an even number. And isn't negative 1 to an even number 1? We'll do the math. But let's say we maybe should notice that about this one. That's an even number. Okay, so, but here we'll prove it. All right, so we put 1 in. What's negative 1 to the second power? It's 1. Okay? And then we put 2 in. What's negative 1 to the fourth power? It's 1. And then we put 3 in. What's negative 1 to the sixth power? It's 1. Okay, so we're going to get that. Okay. All right, so this one, not alternating. Okay. I know I said decide if each alternating series converges, but, well, so we notice this one's not actually alternating. What is it, though? Isn't it the same as this? Isn't that negative 1 to the 2, and it's just kind of distracting? It's just going to be 1. It's this. This diverges. Okay? That series right there will diverge. 1 plus a half plus a third plus a fourth. That's going to diverge. Why? It's a p series. And that's something that if we've gotten this far, we've talked about before. And p is equal to 1. That's why that one diverges. It's not alternating, though. And so I wouldn't try to use the test for alternating series because it's not an alternating series. That test right here, establishing these two things to show a series convergent, that's only for alternating series, and this is not one of them. What about this? Well, let's take a look at this one. So, okay. First term is negative, and it's going to be 2. Okay. And then second term, negative. Okay. Second term is going to be positive, and it's going to be 3 over 2. Okay. And then the third term is going to be negative. Whoops. Third term is going to be negative. Okay. And I put 3 in, I'll get 4 over 3. Our next term, 5 over 4. And then the next term, 6 over 5. And it goes on and on and on. All right. So here goes. Is it true that, so it's an alternating series. Okay, fine. It's an alternating series. Are the terms getting consecutively smaller? Is any term more than the next term? Is 2 more than 3 over 2? That's 1.5, so yeah. Is 1.5 bigger than 1.3? Yes. Is 1.3 bigger than 1.25? Yeah, the terms are getting smaller. Okay? So for this alternating series, any term is bigger than the one that comes after it in absolute value. But are they going to 0? That's the part that doesn't happen. So I can prove that this one diverges just by this part. If I want to establish an alternating series diverges, I just have to show that this limit's not 0. So that's my instinct about this one, is that sure, the terms are getting consecutively smaller, but they're not going to end up at 0. All right. So here's what I'll establish. Limit n goes to infinity. Absolute value an is, in this case, limit n goes to infinity. What is the absolute value of this formula? Wouldn't taking the absolute value of that just entail dropping this -1 to the n? That's the only part of this entire formula that might be negative. So I would just have to do this. To find the limit as n goes to infinity of the absolute value of a sub n, I would just have to say, what's the limit as n goes to infinity of n plus 1 over n? Well, that's 1. And sure enough, these individual numbers are one at a time getting closer to 1. Every number in this series all by itself is closer to 1 than all the ones that come before it. And there's no limit to how close to 1 they'll get. That's where they're going. That's not 0, though. Okay? So what happens if we have an alternating series and this limit is not 0? It will diverge. Okay. So this video, short as far as Calculus 2 videos go. Simple as far as Calculus 2 videos go. But you know what an alternating series is, how to tell if it converges or diverges.